Solving systems algebraically. Algebraically, again, means solve for x, solve for y. And we're going to use substitution. You're going to be substituting something into one equation. Now, our goal for this kind of problem, we're trying to find the point where they cross. We're trying to find x, y. Some coordinate where these two graphs cross. But we don't want to do it by graphing. And the basic idea is you want to first find x or y by taking one equation, plugging it into the other. And with practice, you'll recognize, oh, y equals this. So what I can do is, oh, if y equals that, that means I could take it and plug it right here for this y. Y equals this, so what I can do is I go to the second equation, I take out the y, and what am I going to plug in its spot? X minus 2. I take one equation, I put it into the second equation. Now my new equation has all x's, which I can solve. The reason I can replace y with this is because right here it tells you y is x minus 2. They're the same thing. So I replace it. Now, I can solve for x now. So what I do is, this really messes people up. You got to understand there's a negative 1 there. Negative 1 times x is negative x, or negative 1x. Negative 1 times negative 2 is positive 2. Bring down the 5. Bring down the 2x. That negative idea really messes people up. Now, to solve for x, I got to combine these x's. That gives me x. Bring down the 2. Bring down the 5. And finish solving. Minus the 2 over. I now have x equals 3. So, my x is 3. What do we need now? Y. So if I know x is 3, could I go back up to one of these two earlier equations and find y? Yeah. Which equation looks easier to plug 3 in for x? Hopefully the first one seems easier. Take the first equation. That's the first equation. And all I'm going to do is replace x with what? X was 3. So y equals 3 minus 2. So y is 1. So what this means, 3, 1, this coordinate, 3, 1, is where these two graphs would cross. Okay. Substitution. Now, number 2, are either of these equations nice and pretty set up like this? No. So what we want to do is we want to look at these two equations and go, which one can I easily change to get a variable by itself so I can then plug it into the other one? And looking at this, I look at the top one and I go, isn't that negative n going to be really easy to get by itself? So I'm going to go, okay, the 2m minus n equals 1. I'm going to go, okay, I'm going to try to get n by itself. So first thing I'm going to do is minus this over. That gives me negative n equals negative 2m plus 1. Oh, wait, I got to get the negative off that, so I divide by everything by negative 1. So I now have n equals negative divided by negative is a positive. 1 divided by negative 1 is negative 1. Okay, I have a new equation. I know what n is. What am I going to do with n? I'm going to plug it back into one of these equations. Now, which one would be stupid to plug it into? The top one. Aren't you plugging it back into itself? Yep. You don't plug it back into itself. So I'm going to take this, and I'm going to come and plug it into which one on the second one? The n, because n equals that. So I'm going to take it, and I'm going to come plug it in right there. I'm going to have something like 2m minus 5 times blank equals 8. And what did I put in that blank? It is 2m minus 1. That's what I'm plugging in the blank. Can I now solve for m? Yeah. So distribute first. That would be negative 10m. Distribute this. Oops, went a little far. Negative 5 times negative 1 is positive 5. Bring down the 8. Bring down the 10m. Do you guys see something right here? What's going to happen? M disappears. Wait a second. M disappeared. Remember, there could be no solutions or infinite solutions? Is this a true statement? Does 5 equal 8? No. This is false, right? So whenever M disappears or your letters disappear on you, it's either no or infinite solutions. Since that's false, which one do you think it's going to be? No solution. It's going to be no solution. If that was a true statement left over, it would be infinite solutions. What does no solutions mean? These two graphs are parallel. What does this answer mean? This is the point where these two graphs cross. This is a perfect way of solving them. 100% accurate as long as the person doing it does it right. Graphing's a little more sketchy on getting it